Hello and welcome to Machine Learning First Steps. Today we're going to get a quick introduction for Python, which is one of the easiest programming languages and which makes developing our machine learning projects much easier than other languages. So, what did we do so far? We understood the importance of machine learning for robotics and how it is being currently implemented into so many robotic projects. Also, we learned how to use Ubuntu, and we installed some software utilities that we're going to use later for our machine learning projects. We also knew how to set up virtual environments for our different projects. So what are we going to do in this tutorial is to use Spyder IDE that we've installed in our last video to write quick Python codes in which we will try to understand how Python works and how to write codes using Python. We'll get introduced to variables, strings, and lists, and we'll also use some if statements and some loops, like the for loop, for example. We're going to introduce a very, very important library in our machine learning work, which is Numpy, which is used for vector and matrix operations. And we're going to understand vectorization, which is the implementation of matrix and vector functionalities into Python. So, let's go. So in order to write our first Python code, first I logged into my Ubuntu, and now I'm going to open up a terminal, Control-Alt-T. So now I'm in the base environment. I'm going to navigate to an environment that I said earlier, which is called TF. So I'm going to write anaconda activate TF. I know that the environment that we set up for our last video was called InfSam, but I usually use the TF environment, which is an environment I made for my machine learning projects. So, as I said before, you can call it whatever, just install the appropriate libraries and appropriate packages for that environment. So I'm going to activate that environment, and then I'm going to open up Spyder. And first what I'm going to do is that I'm going to open up a new script. So I'm going to just click File, then New File, and here I got a new script which has some information regarding the author and the date. So what I'm going to do now is I'm going to write my first code. So first I'll use normal variables. So the good thing about Python is that when you get to define a variable, you don't need to specify its type. For example, let us just say that I want to create a new variable x, and I'm going to let it have a value of 10, for example. So let's just say x is equal to 10. And it is simple as that. So if I happen to run this, you'll find here that I have, this IDE offers me like a cool interface for seeing my variables. Here you can find something called Variable Explorer, which basically shows all the variables stored in my current workspace. So we've got a variable which is x, and it got automatically assigned to the type integer, and this is its value, which is 10. So let us just say that I need to print the value of x. So I can use the print function in order to print the value x. So if I run that again, you can find here that it started running, and by the way, this is called a console, which is basically like a terminal within my IDE itself, other than the terminal like located here. So this is the system terminal, and here this is like the console terminal of this IDE. So when I ran the file the first time, it didn't print the value of x, and now it prints the value of x, which is 10. So let us just say that I need to print this in a more presentable way. So instead of just typing the value of x, I need to specify that this is the value of x for anybody who's going to run the code. So instead of just printing x, I might add a string. And what a string is, it's basically like an array of characters. It's basically like normal statement. in which I'm writing a couple of words to specify something or declare something. So what I'm going to type is, I'm going to use like these signs here. I'm not really sure what they're called. I think they're called quotations, I guess. Yep, something like that. I'm not really sure. Anyway, I'm gonna use these signs, and you can see that their color changed to green to specify that I'm going to type a string here. So between quotes, I'm going to write my statement, which basically says the value of variable x is, and it's just gonna append the value of x here to this particular statement. And when I run this, you can find that the value of variable x is 10. All right, I'm just gonna cut a space here. Yeah, cool. So the print function is one of the important functions that you need for printing out things for anybody who's going to run the code, instead of just going to the variable explorer and just navigating through variables. So since we define strings, let us just get introduced to one more string trick. For example, if I intend to make x a string instead of a variable. So let us just say that x, for example, is called summer. And let's define another string y, which says is awesome. So string is a type of variable, and you can define like string variables instead of just numerical values or numbers. And I need to print the whole statement. That means I need to append the second string to the first string. So what I'm going to say is x plus y, and I'm going to run it. So you can find that summary is awesome. We can just add a space here in order for it to show up in a better way. So when I run it again, we got summary is awesome as a whole statement. So this addition operator doesn't actually just add numerical values to each other. Sometimes it's used to append strings, and this is and this shows how flexible Python is. It can use the same operator for different things. So let us get back to some numerical example. So let us just say that x, for example, is 3 and y is 4. So I'm going to print x plus y, and the result I got was 7. But I did not get the result here in my variable explorer because I didn't define a third variable that contains the sum. So what I did is executing this operation and just printing out the result without storing it back into a third variable other than x and y. So if I'm going to do that, I might say that z, or z, depends on whether you're American or British, and z is equal to x plus y, and let it just print z. So right now I get a third variable z, which contains the value 7, and at the same time the value 7 was printed out in my console. So this is pretty cool so far. There are other operations that we can use as well. For example, we can use a multiplication operation, so I can multiply x and y and print out the result. We also could use other operations like the subtraction operation, and we can use the division. Alright. We could also use something like the power operation, and the power operation here is represented in terms of asterisks. So if I run that, we got 81, which is basically 3 to the power 4. These are the basic numerical operations that we're going to need. Basically, we won't need more than that, and more complex operations can be performed using the math library. For example, let us just import something called a math library. And what a library is, it's a basic, it's a library of functions that I'm going to use into my code, for example, or using my code. So these functions were designed or coded by other coders, and they were provided as libraries for me to use right away without having to recreate these functions. So I'm going to import math, right? So it's basically displaying a warning that I'm importing math as a library, but I'm not using it. So I need to use it. So let's just say that z, for example, is, we could type an exponential, for example. I'm not really sure if exponential is part of the math library or is it just like available right away without using the math library. Let's just, oh, all right, it worked. So basically what I did here was importing the exponential function from the math library. Because it's not available right away, I have to use a special function imported from the math library. And whenever I import a function from a library that I have imported or have included into my code, I have to add like some instance or, you know, the name of this library, followed by dot, followed by the function that I'm going to use. So this function is considered to be a method of the library math or the class math. Okay, so whenever you're using, or whenever you want to use like a special function that is actually imported from a library, you have to write it this specific way. Sometimes when you have a very long library name, you can just import the library with a different name. For example, I got math, so I'm going to import it as m instead of math, because math is long and because I'm lazy. So instead of math.exponential, now my program is going to recognize math as m instead of math. So I'm going to write here, it's just going to be m, and I'm going to run it, and I got the result. So if you have like a long library name, you can just use this trick to make it shorter. It's like you are renaming your library in your code scope. So one additional thing we might introduce here is something called a list. So what a list is, it's like an array of variables. It's like a multi-variable variable. So let's just say that I have this variable x here, and I want it to be like an array of variables or a list of variables. So I can type, for example, 1 and 2 and 3. So x is actually 3 variables or 3 numbers instead of just one number. It's like an array of these numbers. So I'm going to print x right now. I'm going to run this. So basically the 3 numbers or the 3 numerical values are printed, and they are within brackets just to indicate that this is a list. So what if I want to print one of these values at a time? I don't want to print the whole list. So we'll use something called or known as indexing, which means that I'm going to pick a specific value out of this list. So I need to access a value here with an address. So by default, the address of the first value is 0, and then 1, and then 2. Here we call the address an index instead of an address. So basically an index means, what an index means is the position of the value that I want to print. So as we said, the index of this one is 0 since it happens to be the first element of this list. So if I want to access that particular value or print it out, I'm going to include brackets and then type 0. And then I'm going to run. So here it displays 1, which is the first value. Also, I might include, for example, the third value, which is 3 here. So I'm going to type 2. And you gotta take care that the third variable doesn't mean that I'm going to include 3 as an index, because as we said, we start with 0. So 0, 1, 2. So it printed 3, which is the element having the index 2. Cool. And the cool thing about lists, unlike other languages, Python allows to append different variable types. So for example, I can let 3 be a string instead. So let it be like a character. So let us just call it S. Let's print it out. So it prints S. So we have different variables. We got the first variable in the list, which is an integer, and the second variable, which is an integer, and the third, which is a character, actually. So it doesn't care. And as a matter of fact, I can type an entire string. Yep, and we gotta print it out. So lists are very flexible, and a list is a very powerful tool. We can also include another list called Y. For example, let it be 4, 5, and 6. And we can actually append one list to another. So we can say x.append Y, and then we're going to print X and see what happens. So I'm going to run this, and right now we got a list appended to another list. We appended Y to X. So actually this is considered to be a list within a list right now. So this is one more thing we can do. We can also get some information about a list. Like, for example, let us print the length of X, which means how many elements does X have. So we can use a function called len and just include X as an argument, which means print the length of X. So we're going to run that, and X has 3 elements. And if you want to use that for strings as well, then no problem, we can do that. So since the third element of the list X happens to be a string, so we need to type the length of the string. So I'm going to type here X2, which means the value of the element having the index 2 in the X list. And let's run that, and we got 5. The reason we got 5 is because my name has 5 characters. So basically the string has a length of 5. So that means that X has length of 3 because it had 3 elements. And the string here, which happens to be an element of X, has 5 elements within itself. So now I'm going to introduce another type of variables known as a dictionary. And what a dictionary does is that it saves several attributes for a certain entity, for example. So let's just create a dictionary. So I'm going to say X is equal to, I'm going to open up braces. So let's just say attributes like, for example, considering that I'm a student, so we can type my own attributes. So for example, we got an attribute called name, and I'm going to specify that to be summer, for example. And I got another attribute like my student ID, for example. So ID, and that is going to be a numerical value. So let's just say whatever, 1300, for example. All right. So what I'm going to do is that I'm going to print the whole dictionary first. So let's print X and let's run. So I got the whole dictionary printed, but what if we want to present a certain attribute? So why don't we say that, for example, Sam name, for example, is equal to X, and Sam name is like the name of summer, for example, that kind of variable. And I'm just going to include my name attribute. So I'm going to write name as an attribute here. So instead of accessing some array with an index, you access it using the attribute that you want to show. So I'm going to type some name here. Let's just print it out. So it printed out my name, and we can use it to print the ID attribute as well. And it printed out my own ID. So we're going to use dictionaries like frequently in our examples. So it's a pretty good tool that you might use quite frequently. Let us also introduce something called a loop. What a loop does is that it allows you to perform the same operation over and over for a specific number of times till you decide to terminate that loop. So we're going to use the for loop because we often use that a lot in our projects or our coding assignments. So let us create a variable or a list called x, and it's basically going to be sequence of numbers. And let us just use a for loop to loop over all of these elements. So I'm going to type for. Now I'm going to define some counter. For example, I, and I is going to be in the range of something. So what does that mean? That means that I is a counter variable that's going to start from 0 and up to the range that I'm going to specify here. So basically, since I want to display all of the elements in X one by one, then I'm going to include the range to be the number of elements, or the number of times I'm going to loop over this particular list. So let's just say 5, for example. So that means I'll start with index number 0, then 1, then 2, and 3, and then 4. Despite the fact that I am terminating my loop with the element of index 4, still I counted 5 turns, so that means I'm specifying the range to be 5 and not 4. So here you can find that the IDE automatically set my cursor here instead of the very beginning of the line. And this is because Python uses something called indentation in order to separate different scopes. So for example, here I'm located within the scope of the for loop itself, not the global scope that I've been using before, or that I've been in before. So in order to let Python know that I'm going to type something that's going to be executed within this for loop or within the scope of the for loop itself, I have to add a tab or some spaces in order for it to understand that. Because in Python, we don't use semicolons as separators between lines as we do in C or C++, for example. So here I'm going to print index number I. So I'm going to say xi, and I'm going to run that, and we can see that the elements have been printed in order as we wanted to do. A cool trick would be to replace 5 with the length of the variable or the list x, so that we can make the code more flexible. In case you change the length of x or you added more elements, still you're going to loop through every element of x. So let us just repeat that, and again we got 1, 2, 3, 4, 5, and even if I change the length of x by adding more elements, we can still print all of these elements as we can see here. Another example I'd like to show concerns the famous if statement, which is used for conditional operations. So let's just say that you want to check if the first element of x is equal to 1. So I'm going to write if x index 0 is equal to 1, and in this case, instead of using the equal assignment operator, I'm going to use equals equals, which refers to the comparison between two values. So I'm going to check if it's equal to 1, and if it's equal to 1, then I'm going to print OK. And we notice here that the orientation is present because the statement lies within the scope of the if statement. And you might run the program right now, and we get OK because that is true. We might change that to be, for example, 0, which is not the case, and we find that nothing is printed because that statement is not true. And we might add like several conditions within the same if statement, like many other options that could be there. So I might write, for example, else if, which is written as if. And we might just write, for example, x0 is equal to 1, which happens to be true. So we're going to print, for example, option 2 is OK. So let us just run that. And yeah, so the thing is, it just passes through this condition, and the condition doesn't sound true. So it moves on to the second option, which is index number 0 has a value that is equal to 1. And in the end, if you've exhausted all your other options, you can just type else and print, for example, nothing is OK, for example. And you can just change that to be 4, for example. Right? So if I run this right now, so it says nothing is OK because none of the other conditions are true. So basically, I executed the statement that followed the else keyword. So the last thing I'm going to talk about in our little Python tutorial is a very important library called Numpy. And what Numpy does is that it's responsible for all matrix operations. And you can find that the core of machine learning programming relies on matrix and vector operations. So I'm going to import Numpy. And in case you don't have Numpy installed in your virtual environment, you can just you can open up a new tab using Control-Shift-T and just type conda install Numpy if it's not there. But I think once you install Anaconda or Conda, you have Numpy installed by default. And because Numpy is such a long name, I'm just going to import it as MP instead of Numpy. So what Numpy does is basically, well, I can use it to just change this list into an actual vector or an array. So we call a vector a Numpy array here. So I'm going to say mp.array, and I'm just going to include these between brackets, and then we got ourselves an array. So now x will be saved as an array instead of a list. And you can see that x here changed from a list to an array of integers. So let's just try some operations using Numpy. So let us define another vector called y, and let us just say, well, we can let it be of the same length as x. So 7, 8, 9, 10, 11, and 12. So we can try multiple vector operations, such as we can add the two vectors, for example. So we can print x plus y. So let's print that, and you can see that the result here is the addition of two vectors, which is also a vector of the same size. So what happens if I change the length of y and let it be, well, we got 6 elements here in x and 7 elements in y. Let us add those together, and you can find that the console displayed an error because we tried to add two vectors that are not of the same length, which is forbidden in matrix mathematics. So what we can do is we can also multiply both vectors. And here we have two types of multiplications, which is element-wise multiplication, which multiplies each element in one array by its corresponding element of the same index in the other array. So the way to do that is to say x times y, for example. So here we got both arrays multiplied in an element-wise fashion. So there is also the matrix multiplication, which happens to be that sort of multiplication which has like a size constraint. So whenever you have to multiply two vectors or two matrices, they have to have the same element or the same number of elements across a certain axis or in a certain axis. So here we got x, which has a size of 6 times 1. So we got 6 elements, and as a matter of fact, let's just type the shape of x. So here you can actually display the size of x by using x.shape. So here you got a vector which is basically 6 times nothing, which means this is a vector which contains 6 elements, and it's only considering one axis this time. So in order to make it a 6 times 1 vector rather than just 6 times nothing, we can do the following. So we can just maybe we need 6 rows and 1 column. So here we can do this. In order to have a matrix of 2 dimensions, even if one of the dimensions happens to have a size of 1, it's still a 2-dimensional matrix. So we have to have like 2 sets of brackets instead of just 1 set of brackets. And then we can run it now, and we can see that the size of x now is 6 times 1, which is what we want. The same goes for y. We can just let it have a size of 6 times 1. So I'm just going to include brackets in order to make it a 6 times 1 vector, and you can call it a 6 times 1 matrix since they're basically the same thing. And we can print y.shape here. And yes, we have a 6 times 1 vector. So in case you want to perform matrix multiplication, the rule is in order to multiply these 2 vectors, you have to multiply one of them times the transpose of the other. Because there is a size constraint in matrix multiplication where the number of columns of the first matrix has to be equal to the number of rows of the second matrix. So in order to perform this multiplication, we gotta say np.matmul, which is short for matrix multiplication, and then you got x, and we need to transpose y before doing this operation. So in order to transpose y, we can say either y.t, which means transpose of y, or you can simply use the full command, which is np.transpose y. So we multiply both together, and because x is 6 times 1 and y transpose is 1 times 6, then you eliminate the 1 and you just have a matrix or an outcome, which is a matrix of size 6 by 6. Also, you can actually transpose x instead of transposing y, and you'll get a totally different answer. So now we got a 1 by 1 matrix because you multiplied a 1 times 6 vector times another 6 times 1 vector. So the 6 gets eliminated and you get a total output size of 1 times 1. Also, if you want to make this a little bit more compact, you can just type add, which means the matrix multiplication. And you got to differentiate between the add sign and the asterisk sign of multiplication. So asterisk is for element-wise multiplication, and add is for matrix multiplication. So if we do this, we get the same result. And say we need x to be, for example, a 6 times 2 vector instead of just having this. So we can get everything back as it was. All right. And we can include a second row. So it's going to be a 2 times 6 matrix. And we can just include 3, 4, 5, 6, 7, 5 elements, so 8. Yeah, so now x has a size of 2 times 6, and y has a size of 6 times none. So what happens if we map all both? So x has, as we said, x has a size of 2 times 6, and y has a size of 6 times none. So you can find that the result basically is 2 times none. If we show the shape of that and we just say z is equal to x multiplied by y in a matrix multiplication fashion, and we just print z, then we get the same result. And let's print z.shape. So now we have a 2 times none. So none is considered as a size, despite the fact that none doesn't actually mean anything, mathematically speaking, but still it's considered to be a size programming-wise. So none is still a size. But usually you would prefer to have like matrices of 2 dimensions, or maybe more, but not just 1 dimension, because 1-dimensional matrices, like 6 times none, for example, or 2 times none, sometimes cause trouble while working on your project. So it's just better if we always include a second axis for our operations. And that's it. In order to sum up what we did today, we got introduced to Python programming language, and we are now armed with an arsenal of software tools that will allow us to work on our machine learning projects. Now we're ready to learn machine learning theory and apply it in some mini projects that are going to focus on some important aspects of machine learning theory and machine learning applications in robotics.